Okay, so yesterday we talked about scalar versus vector quantities. We talked a little bit about the difference between speed and velocity, and a little bit about distance and displacement. We didn't get into that quite as much. Okay, so quick review. Scalar quantities are quantities that have only a measured value. Okay? Whereas a vector quantity has a measured value, but also a direction. So magnitude and direction, as the despicable me villain would tell you. Okay, right? You guys remember back to the despicable me? Okay, so it's actually accurate. Okay, so vector quantities have magnitude and direction. So we talked a little bit about, at the end of the day, using this diagram, I believe, the Google routing here to the zoo. Okay, and we talked about how even if you follow this route, okay, so if you follow this route, that your distance traveled will be 42.8 kilometers, and that will take you 30 minutes. Okay, that much is true, obviously, because that's the route you followed to get there, right? What is also true is this, that you will be about 37.5 kilometers from your starting position at 13 degrees west of north. Okay? One of those is your distance traveled. That's the 42.8 kilometers. The other is your displacement. Okay? In traveling from here to the zoo, both are true. They are the same trip from different points of view. That's why I told you the Star Wars story about the story of Darth Vader and Anakin Skywalker. They're the same story, but they're from different points of view. Okay? That is true here. Both of these things have happened. Okay? When we're talking about the scalar version of this trip, I had to make a whole bunch of turns and follow this path and blah, 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 okay, and finally get to the zoo. And when I got there, okay, I had actually turned my odometer in my car over 42.8 kilometers. Okay? When I get to the zoo, my position has changed from here to here. That's displacement. Displacement is how much and in what direction you change your position. It is always the straight line between where you started and where you finish. Okay, is everybody kind of clear on the difference? Distance, that means, will always be either, and most of the time, bigger than displacement, or equal. Okay? And it'll only be equal if you are actually able to travel in a straight line from A to B. Okay? Distance is almost always going to be greater because you have to go a whole bunch of different directions and make turns. Okay? That's why it's a scalar quantity. It can't have direction. But when it comes right down to it, I started here and I ended here. From a vector standpoint, that is what I did. I changed my position by 37.5 kilometers, 13 degrees west of home. Okay, everybody all right with that? Okay, do both of those trips take 30 minutes? Well, I just finished saying they were the same trip, so yes. Okay, it's not two different trips, it's two different points of view of the same trip. So they both take 30 minutes. Okay, everyone all right with that? Okay, so now we're going to look at kind of a more real world example here that you might do in town. So let's say you want to go from your house to Walmart. Okay, unless you live right behind Walmart, you can't walk in a straight line from your house to Walmart. Agreed? Okay, so let's say you leave your house, okay, and you walk out onto your street, and then you take your street to another street, and then maybe you get on Southridge Drive and you go across the river, and then you turn into Walmart. I don't know how you get there. I don't know where your house is. Okay, I'm just drawing a line that represents the path that you might take from your house to Walmart. Is it a straight line? It's not. Okay, let's say that by the time you get to Walmart, you have traveled 4 kilometers. Okay, is that a distance or a displacement? That's a distance. Doesn't have a direction on it, does it? Okay, it's the path I followed. It's how far I actually had to, let's say, walk, okay, in order to get to Walmart. I had to walk 4 kilometers. Okay? Is that actually how far away Walmart is from your house? In a straight line. No. Shortest distance between 2 points is always a straight line, right? Okay, so there's a second way to look at this, and that's the vector point of view. In fact, let's actually use the line tool and draw a nice straight line here. Actually, let's make it an arrow and let's make it red. Okay, so that arrow there represents my displacement. Okay, if I had a helicopter, I sure wouldn't shop at Walmart. Okay, but I don't have a helicopter. But if I had a helicopter, okay, this is how I would fly in a straight line from my house to Walmart. Okay, everybody all right with that? Okay. Now, let's say that this trip, the purple one, okay, so the purple line, let's say that that took you 30 minutes. Let's say 0.5 hours, just so that we're going to get easier to deal with units. Okay, so you walked 4 kilometers, it took you half an hour. How fast were you walking? How far would you have gone in an hour? 8 kilometers. 8 kilometers per hour. That's how fast you're walking. Okay, how did I figure that out? Okay, V equals D over T. Okay, I don't see this picture down on anybody's paper. Draw this picture. Okay, this is going to be your example of scalar versus vector quantities and using V equals D over T. So you're definitely going to want to have it as an example. All right, I'll give you a second to get it copied down. Okay, so if I want to find speed, okay, the units for speed are things like meters per second or kilometers per hour, right? They tell you the rate at which you cover distance, this many kilometers every hour. Everyone okay with that? Okay, that's why this formula works. Okay, I'm going to be dividing the distance, 4 kilometers, by the time, half an hour. When I divide kilometers by hours, I get kilometers per hour. Okay, so when I actually do this math, I'm going to have 4.0 kilometers divided by 0.5 hours. Okay, when you divide anything by 0.5, it's like multiplying by 2. Okay, and what you're going to get is 8.0 kilometers per hour. Okay, which is, if I kept walking, how far I would go if I walked for an hour, right? I'd go 8 kilometers. Okay, so that's the scalar description of the trip from your house to Walmart. Okay, the vector description is this red line. Okay, so let's say that that red line, which would represent your change in position, your displacement, okay, let's say that that's 2.8 kilometers. Okay, and because it's displacement and it needs a direction, let's say it's at 35 degrees south of east. Because that's about what it is, right? If I was drawing a triangle here. Okay, this would be about 35 degrees. That's east, that's south, southeast. Okay. How long does it take me to displace myself, that 2.8 kilometers at 35 degrees south of east? How long does it take me to do that? Same trip, different points of view. How long did it take me to walk there? Half an hour. Since it's the same trip from different points of view, it takes me a half an hour to do this as well, because I do them at the same time. Okay? They're not different trips. I didn't split in half and do both things at the same time. I actually did both things at the same time. As I was walking, I was also displacing myself. Okay? It takes the same amount of time to do both because they're the same trip. Okay? It's just looking at it from a scalar point of view with no direction and a vector point of view with direction. So the time is the same. 0.5 hours. Okay, so I want to calculate now my velocity in walking to Walmart. Well, that's this formula. No, I'm not going crazy. That's a different formula. Okay, there are little arrows over top of the V and over top of the D. Okay, because that V is velocity and that D is displacement. They're vector quantities. Vector quantities get a little arrow over top of them to let you know they have magnitude and direction. Okay, so if I want to calculate the velocity, it's going to be 2.8 kilometers at 35 degrees south of east divided by 0.5 hours. Okay, I'm just plugging numbers into a formula, right? Okay. That's going to give me 5.6 kilometers per hour at 35 degrees south of east. Sorry. Okay, is it basically the same operation we did for the scalar one? It is, and we got the same units. We got kilometers per hour. Only difference, I had to carry over the direction. And it didn't change. Is that okay? Is it okay that my velocity, which is how fast I did the trip, has the same direction as the direction I walked? It absolutely is. I don't know how it could ever be anything else. Can you go west by walking north? Okay, your velocity and your displacement are always going to have the same vector because one is a measure of the other. Okay, they have to have the same direction. Okay, all right, everyone okay with the use of that formula so far? Okay, same trip, different points of view. Okay, that part's usually simple enough. Now, this is where displacement and velocity start to really differ from speed and distance. Let's say you get to Walmart and you've forgotten your method of payment, whatever that is, your phone, your wallet, both. That's never happened to me, ever. Okay? Well, you're not going to walk through Walmart for fun. Maybe you would, I don't know, I wouldn't because I don't really like it. Okay? But I'm not going in there, so I turn around and I walk exactly the same route home. And a half an hour later, I arrive at home. What's my total distance traveled to Walmart and back? It was 4 kilometers there. I walked the same route back, so that's another 4 kilometers. What's my total distance traveled? 8 kilometers. Okay, so if I go all the way back home, my total distance is 8 kilometers. I arrive back at home an hour after I left. Is my speed still 8 kilometers per hour over the whole trip? Total distance over total time, right? 8 divided by 1 is 8 kilometers per hour. Okay, here's where it changes. When I get home, what is my displacement from where I started? Remembering this, displacement is your change in position. My starting position was home. My final position was also home. How much have I changed my position? Have I changed my position? Okay, so what's my displacement then? 0. My starting point and my ending point are the same place. I walked in circles. Okay? Does that sort of make sense? Right? If I walk to Walmart and then I come home, from a vector perspective, I've spent an hour accomplishing absolutely nothing. Except getting some steps in. Which, by the way, is distance, not displacement. Okay? Everyone all right with that idea? Because displacement is your change in position, if you end up where you started, you have not changed your position, and thus have not displaced yourself from where you started. Okay, so if my displacement is 0 when I get back home, what will my average velocity over the whole trip be? If velocity is displacement divided by time, my displacement is 0. What's 0 divided by anything? 0. Makes sense, right? How can I have a rate at which I change my position if I don't change my position? Both would be 0. Okay, so if you wind up back where you started, you accomplish nothing from a vector perspective. From a scalar perspective, I walked 8 kilometers in 1 hour. Okay? From a vector perspective, I walked nowhere in 1 hour. Okay? Weird, same trip, different points of view. Okay? That's where it gets a little strange. Okay, everybody all right with that idea? Okay, so we're going to start working on some V equals D over T problems here, but I need you to keep in mind that when you look at something from a vector perspective, it's very different than from a scalar perspective. Now, applications here. In your car, there's a little gauge, usually right under the speedometer, that tells you, or it's called the odometer. Okay? Does it tell you the distance you've driven your car or the displacement of your car? Distance. Why is that important? Why is it important that it measures distance and not displacement? If it measures displacement, what's it going to read every time you come home? Well, actually, it'll read how far it is from the dealership you bought it at to your house. If you take it back to the dealership, it'll read. It was a trick question. Yes, technically, yes, it would read 0 because you're going to come back to the position you left from. Okay, so it'll always read 0, which is great if you want to sell it because then you can say, hey, it's this old, but it's got no miles on it because look, it's got 0. It's not practical to use displacement to tell you how far a car has been driven. Okay, you want it to say, how far has this car been driven? That's distance. That number always gets bigger. Okay, you cannot make the odometer run backwards. You used to be able to. Okay? I don't know if you guys have ever seen the movie Ferris Bueller, but they actually did that. They ran the odometer back on a car by putting it in reverse and making it go backwards. That doesn't work. Okay? Driving a car in reverse still makes the odometer go forward. Right? So distance, different than displacement. Okay? Distance is how far did I go. Doesn't care where I ended up, just how far did I go. Displacement cares where did I start, where did I finish, how far apart are they in a straight line, and what direction are they in a straight line. Okay. All right. Okay, so distance, that's the scalar quantity. Okay, displacement, that's the vector quantity. We already have the numbers up here. Okay, we've already dealt with those numbers. Okay, and then this was the, if I come home, what's my total distance traveled? It's 8 kilometers, it's there and back. What's my displacement? 0, because I came back to where I started. All right, so a little bit of terminology here. Okay, you guys will want to write this down. Get those copied down. Okay, so the big thing to remember here is that when we're talking about any vector quantity, okay, that we're talking, especially when it's displacement, it is how much did you change your position by, okay? Not necessarily how far did you go, okay? Just how much did you change your position by, okay? All right, does anybody still need that? Yeah, okay. All right, so we're gonna look a little bit here at the use of V equals D over T. Okay, so that's this formula here. Now, they both work the same, so I'm only gonna show you with this one. All right, this is gonna work just like the mole equation did. We wanna follow our 3 rules of algebra. Okay, just as a quick review. Okay, if I wanna move something, I do the opposite operation. So if I'm dividing by something to move it, I multiply. Okay. Second rule of algebra, what I do to one side, I have to do to the other side. Right? And the third rule of algebra, we won't need for this 3-variable formula, but move what's not attached first. Okay. So if I want to solve for D, right, what do I have to do with T? Right, multiply both sides by t, because right now I'm dividing by t. So if I want to move it to the other side, okay, I put t on the top, t divided by t is 1, so it cancels, and what I do to one side, I do to the other, t times v equals d. All right, something you can do if you're not confident in your algebra, something you can do to confirm whether you've done it right, okay? The units for time, let's say, are hours. The units for speed are going to be kilometers per hour. What are the units for distance? Distance would be measured in kilometers. Okay, when I multiply hours, which is the same as saying hours over 1, by kilometers per hour, The hours cancel, I'm left with kilometers. Okay? You can always do what we call a unit check, okay, to see if you did your algebra right. If you plug in the units to the formula and you get the right units for what you're looking for, then you manipulated it correctly. Okay, so that's going to give me kilometers, okay, for D. We don't always use kilometers per hour. In physics, we actually use meters per second quite a bit more than we use kilometers per hour. Okay, questions on how that works? Okay, now let's solve for T instead. Okay. So what a lot of people will say if they want to isolate T is they'll say, I got to move D. Right? And they'll say, if I just divide both sides by D, that leaves T by itself, which isn't wrong, but it also doesn't solve for T. Okay, I just want to show you why that is. Okay, if people say, I want to move D, so I'm just going to divide both sides by D, okay, D divided by D is what? 1. So when I do this, okay, and if I divide both sides by D, I've got V divided by D equals 1 over T. Is that the same as T? It's not. That's like saying 1 over 2 is the same as 2. Clearly, those are not the same thing, right? 1/2 is not the same as 2. Right? So what I would do in this situation, okay, when I'm manipulating this formula, if I want to solve for T, when I'm manipulating any formula, what I want to solve for needs to be on the top of the equation. Can't solve for it if it's on the bottom. So what I do is I start the same way we started the last one. I multiply both sides by T. Now T is on the top. Now what do I do with V? Divide it over to the other side. Okay, so I'm going to have that T will equal D over V. Do a unit check. Kilometers divided by kilometers per hour. Kilometers cancel, I'm left with hours. I did it right. Okay? That's the only manipulation we didn't have to do in chemistry. Because that's solving for big M, and we never had to solve for big M because we always used the periodic table to get it. Okay? We're going to do a lot of algebra. Don't let that freak you out. Okay? It's like anything else. The more you do it, the easier it will get. It is, after all, just 3 simple rules. Okay? And once you do it, you'll be good at it. Okay, so that's the manipulation of V equals D over T. See the thing on the right? That's a triangle. I had better not see any of those anywhere on anybody's work, ever. These triangles suck. Okay? They are no good for algebra. And right after we do this formula, the next formula we do, a triangle won't work for. And pretty much every other formula we do, a triangle won't work for. Okay? Like, for example, we're going to be doing this by the end of the unit. Solve for VF. Find your triangle. Good luck with that. I'm pretty sure there ain't no triangle gonna get that done. Okay? It's just not gonna happen. You gotta learn those rules of algebra. Okay? Like, yeah, in junior high, did the triangle work? Sure it did. You never had to do anything harder than V equals D over T in junior high. You did Ohm's law and stuff like that, and a triangle worked. Okay? But you get kind of used to it, and then you don't kind of practice how to do it the right way. That's right, I said that. The right way. The triangle is the wrong way. Okay? Algebra is the right way. All right? Don't freak out. That's not as hard as it looks. Okay? When we get there, you'll see. All right. Okay, so 3 rules of algebra, just quick review. You wrote these down in chemistry, so they are in your notes somewhere, but you know what? You probably don't remember where in your notes those 3 rules of algebra were. So put them down for your physics notes, and you can refer back to these. Okay, give you a minute to get those written down, and then we're going to put them to work. All right, so let's say we have this formula, because this is one we're going to use in this unit. Okay, I want to solve for VF, right? What, according to the rules of algebra, should I move first to isolate VF? What makes the most sense to move first? Third rule of algebra says move what's not attached first. What is attached to VF? VI. VI is attached to VF. So what do I need to move first? T. How do I move T? Right now I'm dividing by T. What's the opposite of divide? Multiply. Okay, so now I'm going to multiply both sides by T. Okay, so that's going to cancel T from this side and bring T over to this side. So T times A equals VF minus VI. All right, I still want to isolate VF. So how do I move VI over to the other side? Oh, what's the opposite of subtract? Add, right, okay. So I want to add VI to the other side, okay? Because if I add VI to negative VI, that makes it go away. Okay, I just solved for VF. And I couldn't use a triangle. But the rules of algebra never fail me. Okay, as long as I follow them, I can do this. Okay, how many people are taking Math 10C right now? Okay, just one, all right. So then not many of you have seen this formula, which we will be using very soon. Okay, y equals m times x plus b. Okay, so I want to solve for m. What should I move first? What's not attached to m? X is attached to m. What's not attached to m? B, yeah. Okay, because m, it goes like this. M times x, that means m and x are attached, right? The plus b, that's outside of that. Okay, so m and x, because they're right beside each other and being multiplied by each other. Think order of operations. If you're ever having trouble figuring out what's not attached, okay, think about what would I do first in terms of order of operations. I would have to multiply these two numbers before I added b, right? You do multiplication and division before addition and subtraction. Okay, so I want to move b. Right now I'm adding b. What's the opposite of add? Subtract. Okay, so I'm going to subtract b from both sides. So what I'll have is y minus b equals m times x. Okay, I still want to get m by itself. Right now I'm multiplying by x. What's the opposite of multiply? Divide. Okay, so I need to divide both sides by x. Okay, x divided by x is 1. Okay, divide this side by x. Boom. I've isolated m. Okay, it really doesn't get much harder than that. You just have to follow those rules of algebra. Probably the trickiest part, okay, is deciding what's not attached, so you know what to move first. Okay, otherwise just follow the rules. You can't go wrong. Okay, I want you to write that one down. We're going to walk through it together. Okay, it's going to be our first V equals D over T question. All right. When a question asks how far, we talked about this yesterday, okay? Something wants to know how far something is. What does it want to know? Is it displacement or distance? Distance. If it wanted displacement, it would ask me how far and in what direction, because displacement is a vector quantity. Okay? This is just asking how far. All right? How far, that's distance. Okay. Will a deer running at 15 meters per second, what did they just give me? What does meters per second measure? If it said meters per second south, if the south would be the vector. This just says meters per second. Meters per seconds are a unit of speed. It's how, like, speed measures how much you, or how quickly you change your distance, right? That's how many meters every second, or how many kilometers every hour, okay? Or how many centimeters every year. We're talking about how fast a glacier moves, right? Like, it all depends on what units are appropriate, but it's always going to be a distance measurement over a time measurement, because that's the formula, right? V equals D over T. All right, so they're giving us the speed, in this case, because there's no vector, 15 meters per second, okay? And 45 seconds, what's that a measure of? Time. All right, so very much like a mole equation problem, any problem-solving question, the first thing we want you to do is write down your givens. All right, we're looking at units, we're looking at context, what's speed, what's distance, what's time in a question. Okay, so right now I've got V and I've got T, and the question wants me to solve for D. So probably going to be using that formula, right? Incidentally, you still do need your periodic table, because on the back of it is the formula sheet for physics. Okay, so wherever you got that, dig it out, because you're going to need that. No, not right now. We're just using V equals D over T, but you are going to need it for this unit. Okay, there's a lot of formulas on there. Okay, so I've got V equals D over T. I'm looking for D. What do I have to do with T? Multiply, because right now I'm dividing by, right? Rules of algebra say do the opposite. All right, so I multiply both sides by T, and I'm going to have T times V equals D. Okay. And then I can plug in my numbers, just like we did with the mole equation. So that'll be 45 seconds times 15 meters per second. What's going to happen to the seconds? They're going to cancel, and I'm going to be left with meters, which are the units for distance. Okay, distance will equal, okay, 45 times 15, 675 meters. That's really fast, by the way. And to give you an idea, the Olympic/world record for the 400 meter, okay, for people is 42 seconds. Okay, deer is quite a bit faster than we are. All right, so where would you get your marks in a question like this? You'd get a mark for givens, just like you did with the mole equation. And you get a mark for picking the formula. You didn't get that mark back in the mole equation because there was only one formula. Now, you've got a formula sheet with over a dozen formulas on it. You actually get a mark for picking the right one. How do you know which one to pick? Whichever one's got what you got, that's the one you pick. Okay? Like, for example, if I'm looking at my formula sheet and these are my givens, I'm pretty sure I don't need that formula. right? That formula is not gonna work. I don't have kinetic energy or mass, okay? So that's not a formula I would use to solve this question. Just pick the one that's got what you've got. Then you would get a mark for this step. That would be the manipulation / the plugging in of the numbers, and then a mark for your final answer. Okay? Very, very similar to what you did with the mole equation. All right, any questions on that? Okay, write this one down. We'll walk through it in a minute. So on this one, we're looking for how long. They want us to solve for time. Yeah, how long is time? So we're looking for time in this one. Okay. How long will it take a tortoise to crawl 200 meters? What did they give me there? Distance. How do I know it wasn't displacement? I didn't get a direction. All right, so it's crawling 200 meters. And it does so at a speed of 0.25. That's nice. They just tell me outright that that number is speed. Sometimes you're that lucky. Okay, 0.25 meters per second. Okay, so there's our givens. Okay, obviously, since this is the formula we're working on, this is the formula that we're going to use. I want to solve for t. Right? This is the trickiest manipulation of this formula because it's 2 steps. First, I want to get t off the bottom. So where do I move it to? To the other side. Okay, right now I'm dividing by t, so to move it to the other side, I multiply. Right. Okay, so multiply both sides by t. Okay, t comes over here. All right, so by the way, you got that mark there for the original formula. All right, now I want to get t by itself, so I would divide both sides by v. Okay, v would come here, okay, just because that's getting messy, it'll look like this. T equals d over v. And then we just plug in our numbers. So that'll be 200 meters divided by 0.25 meters per second. Right, when I do that, meters are going to cancel. I'm going to be left with seconds. That's units for time, so I did this right. Okay, that should be 800 seconds, I believe. Yep. Okay, everybody all right with that one? Pretty like cookbook in terms of follow these steps and you'll get to the answer kind of thing. Okay, these ones aren't requiring us to do a lot of thinking. Okay, we're just kind of introducing the formula. They'll get a little bit more complex in terms of the story being told. Okay, but the math's never going to get any. Okay, well, let's have a look at this one. Okay, so this one is a vector problem. Okay, so I want you to copy this one down and then we'll walk through it together, okay, just so you see how the difference, how it goes when we're talking about distance versus displacement and speed versus velocity. Okay. So this is a question that's got a bit more complex story. In fact, it's a story with 2 parts. Okay, there's a part where it's going north, and there's a part where it's going south. Okay, so this is where vector and scalar are going to start telling different, well, the same story from different points of view. Okay, so what we want to do is still write down our givens. But because there's clearly a bus travels north part and then clearly a bus travels south part, I'm going to separate those two into their separate parts. Okay, so I'm going to write down my givens like this, and I'm going to say part 1. Okay, in part 1, the bus travels 100 kilometers north. What did they give me there? Well, it could be a distance, but it's also because I got north on there, displacement. Okay, so I'm going to write that it's a displacement. I can easily turn displacement into distance because this is a straight line. They're the same number, just without the north. Okay, but I'm going to write it as 100 kilometers north. Okay, and it does that in 1.2 hours. What did they give me there? Time. Okay, that's all I know for part one. Okay, then it says the bus turns around and goes south. And in the south part, it goes 62 kilometers. So again, another displacement, 62 kilometers south. And this takes 0.9 hours. So did I get another time? Yeah, okay. Okay, so it wants to know the average velocity of the bus. Okay, now this is going to seem a little bit different because up until now, you've been taught how to calculate averages is take the things, add them together, and divide by the number of things. Agreed? Okay, and that's fine, provided all the things represent an equal part of the whole. Okay, so if I'm calculating a class average, okay, on a quiz or a test, in here, I take all of your marks, add them together, and divide by the number of you, because each of you represents an equal part of the entire class. I can't do that here, because part one is bigger than part two. They don't represent equal parts of the entire trip. Not only does it go further in part one takes longer. Okay? It represents a greater percentage of the entire trip than part two. I can't just calculate their velocities, add them together, and divide by 2. Okay? Because that's saying they represent equal parts of the whole. So here's something we haven't learned yet about this formula. And this formula. It's not written on these all the time, but it should be. This formula actually means this. Average velocity equals total displacement divided by total time. Okay, that formula actually always calculates average velocity. Just we haven't used it in a trip with more than one part until now. Okay. The same is true for the speed formula. Average speed is total distance divided by total time. Let's do the speed, but actually it wants the average velocity of the bus, so let's do that. The bus goes 100 kilometers north, and then it goes 62 kilometers south. Does it backtrack on itself? Okay, if I'm looking at that trip from a diagram, right, this is part one, okay, and it's 100 kilometers north. This is part two. It turns around and goes 62 kilometers south. So how much have I changed my position given that this is my initial position and that is my final position? How far away am I now? 38 kilometers in which direction? North. I went 100 kilometers north, and then I turned around and went 62 south. I am still 38 kilometers north of where I started. Agreed? Okay, that's calculating total displacement. Okay, in Science 10, you will never have to do any trig. Okay, we're never going to go, hey, they went 100 kilometers north, and then they turned and went 50 kilometers east, and now find the angles and the hypotenuse and all that. You do that like the second day of Physics 20. Okay, but in Science 10, it's always going to be positive and negative. North, south, right, left. Okay, it's always going to be one-dimensional. All right, everybody with me there? Okay, so you'll never have to do anything more complex than what you just did here. All right, so my total displacement then is 38 kilometers north. What's my total time? This part took 1.2 hours, second part took 0.9 hours. Total time spent on the road, 2.1 hours. Okay, I subtracted the displacements. Why did I subtract the times? You can't. Time is scalar. You subtract time, it means you went back in time. Okay, this is not a 1984 silver DeLorean, okay, going 88 miles an hour. Okay, it is not going back in time. Okay, time can only go forward, just like distance can only get bigger. Okay, it's a scalar quantity. You can't ever subtract it. Okay, so what we're looking at here then is a total time of 2.1 hours, 1.2 plus 0.9. Do I now have enough information to use this formula to calculate my total displacement? I've got the total displacement, sorry, average velocity. I've got the total displacement and I've got the total time, right? I just need to plug those numbers in. So 38 kilometers north divided by 2.1 hours. That's going to give me 18.1 kilometers per hour north. Okay, remember, velocity is a vector quantity, so it also needs a direction. Okay, I want you to calculate the average speed over the entire trip. Okay, I'll give you a couple of minutes on that. Okay, I want you to calculate the average speed. So you will have to use this formula. Okay, you're going to need the total distance traveled and the total time, which, spoiler alert, you already have. Okay, what's my total distance traveled in this question? 162 kilometers. Remember, distance doesn't care which way you go, just how far. You went 100 kilometers, then you went 62 kilometers. Okay? If you were looking at the odometer in the bus, it would read that you had gone 162 kilometers. That's it. That's all it cares about. That's how far you traveled. So your total distance in this is 162 kilometers. That's it. No direction. It's a scalar quantity. Okay? Does that still take you 2.1 hours? Well, it took you 2.1 hours to go 100 kilometers north and then 62 kilometers south. It took you 2.1 hours to go 162 kilometers. The time is the same. It's the same trip. Okay, so I know the total distance and the total time. I just have to plug those in. 162 kilometers divided by 2.1 hours. Okay, so 162 divided by 2.1. Okay, so those numbers are quite a bit different, right? The speed's a lot faster. 77 kilometers per hour versus 18.1, and it's the same trip. How is it I'm going so much faster when I talk about my speed than when I talk about my velocity? Well, because when I'm talking about the speed, I'm talking about 162 kilometers. When I'm talking about the velocity, I'm talking about 38 kilometers in equal amounts of time. Displacement and velocity will always be smaller than, or rarely, equal to their scalar counterparts. Okay? Because scalar quantities don't care if you turn around. They just care how far you went. Okay? It's like if your parents drive into Calgary every day for work. Okay? The car's not resetting when you come home. They have put on probably 160 kilometers or so every day, going back and forth, back and forth. Okay, everybody all right with that? Question. Okay, so write this one down, okay, and you can write it on any piece of paper, okay, and give it a try. Just like the bus, okay, same idea, average speed, average velocity, total displacement, total time, okay, you can look to the bus question to help you with the steps. Okay, I'm gonna kind of set up the givens here just so everyone can have a look at that, all right? We know there's two parts, all right? In part one, the rabbit runs at 22 meters per second due east. Okay, so they gave us a velocity for part one. Okay, and it tells me that it did that for 12 seconds. So they gave me a time for part one. Okay, and then in part two, it runs due west at 17 meters per second. Okay, so our velocity is 17 meters per second west. And it does that for 32 meters. And then it wants the average speed, which we know is total distance divided by total time. And it wants the average velocity, which we know is total displacement divided by total time. Okay, so while the pattern is very similar to the question with the bus, there's about 2 extra steps that you need to do here. Right now, you don't have the ability to get the total distance or distance or total time because you don't have the time for part two and you don't have the displacement for part one. Can you get them? Can you use V equals D over T to solve for the parts you don't have in part one and two? Okay, that's where you need to be headed. Okay, for example, in part one, you need the displacement. You have the velocity and the time. In part two, you have the velocity and the displacement and need the time. Once you solve for those two things, you can do the last part, the total displacement and total time. Okay, give you a few minutes to see if you can get past that little spot there, okay, and then we'll finish it up. All right, so I need the total displacement and the total distance. I don't have distance for part one or displacement for part one, but I can solve for it by taking V equals D over T and solving for D. So that basically means multiplying both sides by T. All right, so I'm going to take my 12 seconds and multiply it by 22 meters per second east. All right, so 12 times 22. All right, so in part one, the rabbit is going to run 264 meters east. Okay, I've got to do the same thing in part two, but I've got to solve for time. So I manipulate V equals D over T, okay, and I go 32 meters divided by 17 meters per second. Okay, and this is meters west. Okay, and this is meters per second west. So the west will cancel. Okay, sorry, it was 32 divided by 17. Okay. All right, so that part only takes 1.88 seconds. Okay, now I've got the distance for both parts, displacement for both parts, time for both parts. So now I can do these things here. Okay, my total distance, 32 meters plus 264 meters, so 296 meters. Okay, okay, so 296 meters divided by the total time. So 13.88 seconds. All right, so 296 divided by 13.88, 21.3 meters per second. Okay, all that changes for the total displacement is now I've got my 264, but this is west and this is east. Okay, so I backtracked. So my total displacement is 232 meters east. The time is still 13.88 seconds. Okay, all that's different is when direction matters, I've got to make sure that I put it in as east and west, and that this was a backtrack. Okay, so for this one, it's 232 divided by 13.88. All right, so now my velocity is 16.7 meters per second. What do I need to put after that? East. Okay, we're going to do more like that tomorrow. Okay, remember, Plant Transport Lab, tomorrow morning, 8:30 they're due.